What's up guys, Onmaths here, and today we are looking at real life graphs, and we've got Edexcel question first up, which is a conversion graph between inches and centimetres, and it asks us to change 74 centimetres into inches. So the first thing we've got to realise is that the centimetres are up here, so we have to look up 74, so we need to know what the scale is. So between 60 and 80, 70 would be halfway in between. And there's two little squares for, one little square for each two, isn't there? Because there's 5 between the 60 and 70. So if we count 62, 64, 66, 68, 70, so that works nicely. So they go up in twos. So 74 would be this one here. And all we need to do is show the examiner that we know what we're doing by drawing a line across from it and a line down where it hits the graph. Should be here. Okay, so we've got to figure out what the axis at the bottom, what inches are going up in. Well, this would be 25 here, so they seem to be going up in ones. So the answer to that will be 29, reading off from the graph. Right. Last question on the Edexcel paper is, it says Daniel's height is 6 feet and 3 inches, 1 foot is 12 inches, what is Daniel's height in centimetres? So if we look at the graph, this only shows inches, okay? So for this question, we need to convert 6 foot 3 inches just into inches. Now it tells us 1 foot is 12 inches. So if we have foot or feet in inches, that should really say feet. Let's just change that. Okay, so 1 foot is 12 inches. And so 6 feet is going to times that by 6, so we need to times that by 6, and 12 times 6 is 72, so it'd be 72 inches, but we've also got the 3 inches as well, because it's 6 feet and 3 inches, so that's the 6 feet, that's the 3 inches, add them together and we've got 75, so we're looking up 75 on the graph. Ooh, we've got a problem here, because the inches only goes up to 50, but if we find out, say, 25 inches, then we can times it by 3 to find out what 75 inches is. So we're going to find out 25 inches, which I've actually marked on here. Let's try and make sure this line goes as precise as I can do it on here. That looks like it's about halfway in between there. So that looks like it will be 63, I think. So it'd be 63 centimetres. So 75, I need to show the examiner, so 25 inches, we're saying is roughly 63 centimetres. Okay, and you can actually show roughly by just having a squiggle like this, just means roughly. Okay, I haven't drawn that very well, let's try and draw that a bit better. So they look like that. It's roughly 63 centimetres. Okay, so 75 inches is going to be 3 lots of that. So we're going to times that by 3. So let's times that by 3, and we can do this nice simple column. 3 times 3 is 9, 3 times 6 is 18. So it'd be 189 centimetres, roughly. Next up we have our OCR question, and here we've got distance time graph, and it's Lucy's car journey from London to Sheffield and a 1 stop at a service station. So use the graph to find how long the car stops at the service station. Okay, so how do we know when the car stopped? Well, the car stops when a distance time graph is horizontal, because it means that time is going but the distance is not, which just basically means they've stopped. So we need to figure out how long that is. So we need to look at the scale at the bottom, and if we look at 11 o'clock, and then we've got kind of 3 jumps, and we've got to 11:30. So that's going to be 10 past, that's going to be 20 past, and then there's half past. So they're going up in 10 minutes, and that horizontal line is 2 of those squares, so that would be 20 minutes. Right, the next question asks us for the average speed of the car in miles per hour between London and the service station. So what we're looking at is the average speed here. Okay, so the time we now know how to work out, because it's going to be 1, 2, 3, 4, 5 squares, which will be 50 minutes. So the time is 50 minutes. Okay, the distance we can read off here, which is what, 50? Halfway between 40 and 60. So the distance is 50. And let's have a look at the units. That's in miles. Now the problem is that when we use the speed, distance, time triangle, which I'm just going to draw in now, so we've got speed is distance over time, and we're looking up speed, so we just ignore that one, and it's distance over time. So speed is the distance, which is 50, because it's 50 miles. Now we've got to be careful with the time. It wants it in miles per hour, but the time is in minutes, so we need to convert that into minutes. Now, easy way of doing that is just divide it by 60. So we can do 50 divided by 60. And this is a calculator paper. I know that paper ones on the other exam boards aren't, but on OCR, paper one is a calculator paper. And we get this 0.83 recurring. Okay, so it's going to be over 0.83 recurring. I'm just going to keep that in my calculator, and what I'll do is I'll press the fraction button and put a 50 at the top, and then I click the answer button just to say put that 0.83 recurring in there. So press equals, and it says 60. So it's 60 miles per hour. And the last part of the question says that Sheffield is 180 miles from London. Lucy arrived at Sheffield at 2:20 or 14:20. Complete the graph. So 14:20. So let's figure out where that is first. So 14:20 is here. So 14:20. And it's 180 miles from London. So we've got London is at 0 because it's from London. So London's down here. And it says it's 180 miles, so it would be up here. So the graph is going to end up here. And all we need to do is go to where the graph finished and just carry it on to that point, like that. I think that could be a bit lower. And there we go. Last up is our AQA question, and there's a lot of stuff missing, or a lot of stuff that we've got to work out here. So the last question, question B, asks us for the average speed, but we haven't really got a graph yet. And question A is telling us, right, draw the graph. So the issue we've got is that the parts of the graph, so the first part of the journey and then the last part of the journey, don't have a distance attached to them. So we definitely need to have our speed, distance, time triangle. We'll definitely need that for this. So speed, distance, time. And the thing we've got missing is the distance. We don't have the distance. So we need to work out what the speed is, or read what the speed is, what the time is, and then work out the distance. So for the first part, and I'll do my working up here just because it makes things a bit easier, because then I'm not scrolling up and down. The distance is the speed, which it says is 40 miles per hour, times the time. Now, we want the distance in miles, and the only way we can get the distance, well, the only way we can do this is if the time is in hours, because the units of speed are miles per hour. So 30 minutes doesn't help us, but we know that's half an hour. Okay, so we're just going to times it by a half. So 40 times a half is 20. So the distance is 20. So in half an hour, in 30 minutes, which is down here on the graph, the distance will be 20. So we can actually plot that on. That'll be here. And we know that they always start at 0, or they normally start at 0 on a distance time graph. And I'm going to try and get, there we are. So we've got our first stint. The second stint says that, or the second part says that she stops for 15 minutes. And we know when she stops, it's just horizontal. So that's 15 minutes. So that'll bring us here. So 15 minutes is 30 plus 15 would be 45. So she'll stop there. Okay, she then completes the journey at 60 miles per hour. Again, we don't have the distance. So we need to do distance equals, and speed times time. Speed is 60. But if she completed it in an hour, then all we've got left is 15 minutes. So it's 15 minutes, but we need that in hours. Well, 15 minutes is a quarter of an hour. So we're going to times that by a quarter. So a quarter of 60. To find a quarter of something, normally you do halve it and then halve it again. So half of 60 is 30, half of 30 is 15. The distance will be an extra 15 miles. So an extra 15 miles will be 20 plus 15, which will be 35. So it will be up here. Or not, because it's 60. Oh, almost there. So what I did was I clumsily didn't look at the graph at the bottom. So it should be here. So what I did was I assumed that that was 60 there. And yeah, the lesson is always check the bottom. So after I did it, I just thought, oh, that looks a bit odd. And so I looked at the bottom, and 60 is not the last one. 60 is the one before the last one. Now we move on to the last question, and we're looking for the average speed for the whole journey. So looking at the distance time triangle, distance times speed triangle, whatever you want to call it. To work out speed, we're going to cover that up. We do distance over time. So the distance travelled, so let's just show the working out. So speed is distance over time. The distance is 35. Now the time is not 60. Remember, it has to be in hours. It's just 1. 35 divided by 1, easiest sum you're going to do on a maths exam. 35 miles per hour. Well, I hope you enjoyed that video. If you did, please click like. If you want to see more from us, we release videos every single weekday, Monday to Friday. Just click subscribe and the bell icon to make sure you're up to date with everything we release. If you want suggestions for after we finish our summer school, specific exam questions you want us to go through, or any other topics you want us to explore further, please write them in the comments below. We read every single comment. If you haven't already, and I'm sure you have, check out our website onmaths.com. It's packed full of free resources to help you with your maths study. And there will be a magical icon which appears above the video right now to take you straight there. Otherwise, thank you very much, and I'll see you on Monday.